Alright, moving on now to this section. We're going to be talking about inequalities. And an inequality is something where two things are going to be not equal. So for example, like if I had 4 plus 2 equals 6, this is called an equation. Hence the symbol in there, which means that they are both equivalent. However, if you have something like 4 is not equal to 6, this right here is not an equation, but now this is going to be called an inequality, and that's because they are not equal. But we have symbols that we can represent the different types of inequalities. And so, for example, if I were to plot 4 and 6, so here's my 4, and here's my 6, and I want to put some kind of symbol in between 4 and 6, and like, what's the relationship between 4 and 6? Well, we can say that either the 4 is greater than 6, right? Or we can say 4 is less than 6, all right, or 6 is greater than 4. So we actually have inequality symbols that we can represent those kind of things. So for example, we would say something like this: 4 is less than 6. And you can see that on the number line, numbers that are closer to 0 that are on the right here, these are going to be smaller than numbers that are further away from 0 on the right. And so those symbols are also represented by different things here. So let me show you what I mean. Let me just go over these real quick. So where there's equal sign with a little line through, then that means that they are not equal. So 3 is not equal to 7. Now this is the less than symbol. Is less than, so -4 is less than -1. This is the greater than symbol, so 3 is greater than -2. Less than or equal to, so this right here, 6 is less than or equal to, to 6, and that is true. So 6 is not less than 6, but it is true that 6 is less than 6. Or equal to it, all right? So it's going to be equal to that. And then we have greater than or equal to, and that's why we say -8 is greater than or equal to -10. So it's not equal to, but it is greater than -10. All right, so let's go over here and let's look at example number 7. So we're going to use a number line to determine whether each statement is true or false. So let's see here. Let's go ahead and plot -8 and -4. So we have -8 and we have -4. So is this true or false? Is -8 greater than -4? Is -8 greater than, right? So this is what this means right here. Greater than -4. Well, just because -8 is further away from 0 does not mean that it's bigger. And actually, as a matter of fact, numbers that go this way get smaller, and numbers that go this way from 0 get bigger. So since -8 is further away from 0, this actually is going to be false. So a big fantastic. So this is going to be false right here. Okay, -4 is actually bigger than -8. Going down over here, is this going to be true or false? Is -2 less than 5? Well, let's go ahead and plug in -2 and go ahead and plot 5. So is -2 less than right here, less than 5? Well, yeah, because if it's to the left of it, then that most likely this is going to be smaller than that guy. So this is going to be true. Okay. Let's look at example number 8. Let's just determine whether or not these are true or false. And if you need to use a number line, you can do that. So is -2 less than or equal to -3? Well, actually, -2 is closer to 0, so this actually is false. Okay, if you look at number line, 0, -1, -2, -3, -3 is right here, -2 right here. So again, -2 is bigger than -3, and this is saying that -2 is less than, so it's false. Is -1 greater than or equal to -9? Well, yeah, that's true. -1 is bigger than -9. We want this to be really small, so that, and the further this goes away from 0, then that means it gets smaller. Is 8 less than or equal to 8? Well, of course that's true, because 8 is equal to 8. And 3 times 4 is 12, is 12 greater than or equal to 12? Well, yeah, 12 is equal to 12, right? So that's going to be true right there as well.